Here is a video on how to find an image, and here we're using a diverging lens because doing the ray diagram is a little harder with them than a converging lens. So here we go. Here's what the diagram is all about. This is our the arrow is our object. So think of that as the flame, the candle flame or something like that. So this is our candle flame, and this is the focal point of our lens. What that focal point means is that when parallel light rays come at the lens, they will go through or seem to go through the focal point. So here's our first line. We're going to draw a line that goes parallel to the lens, and you might want to say, hey, it's going to go through the focal point down here, but no, this is a diverging lens. The light from that ray we're drawing has to go away from the middle, so it has to diverge from other parallel rays. So it's going to come through kind of like this, and I do recommend using a ruler in real life. Use something straight to draw your lines, because the quality always is a little bit lacking when you don't. But anyway, this is the ray that somebody ends up seeing. So we draw a little eyeball to represent somebody looking at that ray. And to them, it looks like this ray came from the focal point. I'm going to draw a dotted line here because that's where it looks like the light came from, but it's not where it actually came from. All right, so that's our first ray. And then our second ray goes straight through the middle of the lens. So that's an easy one. When it goes through the very middle, it goes straight through. And our guy with the eye, we pretend he's seeing that ray also. So the idea is that the image formed is where those lines intersect. And so this is the image you would see. It's above the middle line here, so it's not inverted. It's an upright image, so the magnification is positive. All right, we're back here. We kind of reconstructed our setup here. This is the image that is seen. And this is, it has a magnification of less than 1 since it's actually smaller than the object. And yeah, but the magnification is positive because it's upright. And is it virtual or real? Well, if it were real, actual light should be going to the image, but we saw that it only looks like light is coming from that image. Because remember, the real light ray came parallel and refracted through the lens. So it's a virtual image. You can't put an index card here or a piece of paper and actually see the image there, because the light isn't actually coming from that location. All right, so that's the deal.